Valence electrons, which is a little bit of what we were talking about from number 2 from the homework, and ionic compounds. So ionic bond involves transfer of electrons. The least electronegative species is going to give electrons away. Oh, that's our 5 minutes from our mass break. So they're going to give electrons away, and then the ones that are most electronegative are going to gain electrons. Typically, this is going to occur between a metal and a non-metal. So based on electron configuration, elements will either lose or gain in order to have a complete S2p6 configuration. Loss or gain of electrons leads to that. That's a full valence shell. Ionic compounds are then held together by that electrostatic force, the attraction of the positives and the negatives. Okay? Make sense? Everybody cool with that? But typically, if you see a metal and a non-metal together, that is going to be most of the time, a good portion of the time, 95% of the time, it's going to be an ionic compound. Okay? Valence electrons, first column is going to have 1. And this will have 2, 3, 4, 5, 6, 7, 8, except for helium. Everybody's comfortable with that. Sir?
When you say being an ionic compound, I was trying to see that.
Typically a metal and a non-metal. Okay? Your metal is going to be the less electronegative. It's going to give away electrons. Your non-metal will be gaining those electrons. It's the more electronegative of them.
Why are the elements in the middle missing?
Because they're transition metals, and remember that's your 3, like in this case, it's going to be your 3D level. So when we're looking at bonding, we're looking at the outer electron levels typically. So these are going to be kind of tucked inside there. So this will be your 3 or your 3s, 3p. This is going to be tucked inside there, and then you've got your 4s and your 4p. But fill order, it's going to fill this one, it's going to fill these, and then it's going to fill these, just to make life even more confusing.
Okay.
All right, in order to maintain neutrality, the number of electrons lost has to equal that gained. Because the number of electrons lost or gained is based on electron configurations, elements in the same group will form the same compounds. So for example, if you had magnesium, oh shoot, oh, this won't let me write on here, will it? Okay, just give me a second to, I don't know why it's not gonna let me write on here, but we will make this work. All right, so for example, if we had sodium oxide's formula would look like this. Potassium oxide's formula would look like this. So these are in the same family, okay? They're going to form the same compounds because this is a +1, this is a -2. So you would need 2 +1s to balance out the -2 over here. If we had francium oxide would look like this because they're in the same column. That's what this slide is saying. Make sense? Pretty cool with that? So that's what they're saying about analogous compounds. They're going to be similar. All right. So for example, all metal group 1 will have the same format when combined with any group. So it's going to be all the same. And then if we had group 2 that was combined with group 7, it would look like this. And if we wanted to look at strontium, strontium would be SrCl2. Keep going from there. Everybody cool with that? All right, analogous structures are because the need to maintain that neutrality. Non-metals only want to gain enough electrons to fill their octet, and metals want to give away enough to get a pseudo-noble gas configuration. Now, this want is, you remember, they don't have a personality. Okay, it's not a true emotional need. So don't try to avoid using terms like that when you're actually doing your writing. Okay, makes sense? So is this the, yeah, this is the I do. So calcium reacts with certain elements to form a compound with a general formula, this. What would be the most likely formula for the compound formed between sodium and element X? So we need to figure out what element X's oxidation number is. Okay. Calcium we know is a +2. Okay. So if this is a +2 and I needed 2 of these to balance that out, what does this have to be? -1. Okay. So if we know that X is a -1, and we know that sodium is a +1, that means that this would be our formula. Make sense? All right, see if you can do the next one. Tennessean is right here on your periodic table. When you write the noble gas configuration for it, write it as a, yeah, noble gas. So do the abbreviated. That means the abbreviated one. Okay, so you're going to start with RN and go from there. So you're writing an electron configuration and trying to figure out what it would look like with magnesium. You ready? Need more time? You're going to talk to me? Anybody need more time? Okay. Take a second or two. It's fine. We're not in a rush today. Okay. So when I take this back, Tennessean is here. I'm going to take it back to the previous noble gas, which will be Rn. So I'm going to put that in brackets, and then I'm going to start here on my periodic table. This is 7s2. Then where do we go from here? Down to here, right? Go numerically. It's going to take you down to here. So that, no, not 6. 5, because then remember this is period -2. So this is going to be 5F14. And now we come back up to here. And this is what? 6D. And that's 10. And then we are at 7P. And this is going to take us to 5. So that means that this needs how many electrons to become OG? 1. So if I add 1 electron, that's going to be a -1 for its charge, which means I'm going to need 2 of these for every one of these. Yay or nay? All right. So you've got time to work on this guy. for homework. I also want you to go over your lab for tomorrow. I want you to kind of visually in your mind go through the steps of these. So as athletes, a lot of times before you do an athletic event, you'll oftentimes kind of run through, okay, this is my routine. This is my, how I'm going to go up and approach this, right? My steps that I'm going to take or whatever. That's what I want you to do in with the lab tonight. I don't want you coming in here cold tomorrow and having never read through this or even know what the heck you're doing, okay? So I want you to spend a little bit of time going through the lab. We need to try to come up with lab partners today so that you're ready and you know who you're going to be working with tomorrow. And the other thing is by Thursday, I need your progress check done. Or by Wednesday, I need your progress check done in your packet as well. So you've got a couple things. The rest of your packet's done by Wednesday. And I want you reading through this lab and being ready for that by tomorrow. Okay. The lab procedure is this much. It's not, I'm not asking for a huge amount on reading through this. Okay. There's no calculations. There's nothing like that. So, all right, you good? All right, I'm going to stop this and then I'll hand out your lab. You've got stuff to work on. You guys can work with other people. You can also work on your quiz corrections from last week.